Hi class, today we're going to start chapter 9, which is all about vectors. So we're going to move into vectors. We just finished our polars and now we're going to move into vectors. So a vector is a quantity that has both direction and magnitude. Now when we talk about direction, we mean the angle. And when we talk about the magnitude, we mean the length of the vector. So if we had a vector that was called vector PQ, P is what we call the initial point or the head, and Q is the terminal point in which we call the tail. So for example, if this was P, then this would be Q. So P is the initial or the head, Q is the terminal or the tail. Okay, now this would have a certain direction, right? So if we made an XY axis here, this would be the direction, the angle that it makes, and then the magnitude is how long the vector is, right? So direction means the angle it creates, magnitude is the length of the vector. Now if I flip-flop that, so this would be vector PQ, right? Let's say I had P in the same spot and Q in the same spot, but instead I wanted to have vector QP. That would mean Q is the initial and P would be the terminal point, right? So really what is changing is the direction, right? So the direction of the vector would change, but the magnitude, the length is not changing. Okay, so it's really important you pay attention to what is the initial point and what is the terminal point, right? What is the head and what is the tail, because that changes the vector drastically. Okay, now vectors in standard position can be written in two different ways. It can be written as x comma y with our little vector notations here. So please note these are not an ordered pair. An ordered pair would have parentheses. This is vector notation, okay, meaning we're connecting the points in a ray. Or we could have it as xi plus yj. Okay, these mean the same thing. Now, as I talked about, the direction is the angle that's formed in the positive x-axis in the vector theta. So remember, just like before, if you had to guess, theta is tangent inverse of y over x. Okay, so same thing, and just like in our polars, we have to make sure we're paying attention to what quadrant it is, right? We might have to add 360, we might have to add 180. We have to kind of pay attention to what quadrant our vector is located. Now magnitude, remember, is the length of the vector. So if I want to find the length of this vector here, then just as you would imagine, the magnitude is going to be the square root of x squared plus y squared. Okay, we represent magnitude with our absolute value symbols, right? So the magnitude of the vector would be the square root of x squared plus y squared. Now, if a vector is not given in standard position, so standard position is when the initial point is at the origin. If it's not given us to at the origin, then we need to move it to the origin. We need to move it to standard position. So let's say I gave you P1 and P2, and both of those points are not at the origin. Then in order to write it in the origin, right, in order to move it to the origin and write it in standard position, we have to do the tail minus head. Okay, so we have to do the tail minus the head, right? The terminal point minus the initial point, okay? And then you would find the magnitude the same way as x squared plus y squared. We just have to move it into standard position first. Now we can add and subtract two vectors. It's called the resultant vector. So later when we get into word problems, if I ask you to find the resultant, that means we're doing the sum of the two vectors. Now there's two ways picture-wise that we can talk about how we would add and subtract vectors. So let's say I was given this vector here. We're going to call it u. And then we want to add vector v. So one method is the parallelogram method that says we're going to connect the heads of the two vectors. So if this is vector u, then vector v, I'm going to attach the two heads together. Okay, so here's vector u, here's vector v. I want to add those two vectors together. So I want to figure out, well, what would be vector u plus vector v? Well, the parallelogram method says we're going to complete the parallelogram here. So I'm going to take vector v and place it up here. And then same thing with u. I'm going to repeat u on this side. So I didn't quite make v long enough here. Then u plus v would be the vector that connects the diagonal here. So this would be u plus v. This vector here would be u plus v. Now that just kind of gives you a visual of how vectors work. That's not how algebraically we're going to find the resultant of the two vectors, but it just kind of gives you a picture of what would happen when we're adding two vectors together. It'll help us when we get to our word problems later. Another method would just be the triangle method, which is essentially just this half of our parallelogram. So if I take vector u, and instead of connecting vector v tail or head to head, we're going to connect vector v to the tail of vector u. So I'm just going to connect it here instead. Then I'm just going to complete the triangle, which is exactly what this is. We just connected the heads and made a parallelogram, then connected the diagonal versus right away going to connecting the tail and creating the diagonal. So like I said, this is just to kind of help us visualize how vectors are added, but not algebraically how we add vectors. So let's go into some of the algebra here. So in this problem, it says that we were given c, which is 7, -3, and d, which is -2, -2. So if we were to have a little picture here of what's going on, we have a point C, which is at 7, -3, so maybe that's about here, and then d, which is at -2, -2. We want this vector to go from C to D, and we want it to be in standard position. So we want to take this vector and we want to move this vector to the origin so that it's in standard position. And like I said on the last page, how we do that is we do tail minus head. So we're going to do in this problem D minus C. So we're going to have -2 minus 7, and then -2 minus -3. So we're going to take the tail minus the head, or D minus C, so that we can move this into standard position. So that gives us -9, 1, right? So let's say I graph that. -9, 1 would be right here. So that would be the vector CD in standard position, right? So we took this vector, we didn't change its length, we didn't change the direction, we just physically moved it to the origin. That way it's easier for us to find the length, and it's easier for us to find the direction, right? We know it's in quadrant 2, so it's going to have an angle somewhere between 90 and 180. Okay, so it just helps us move it to standard position so that we can find important information about the vector. Now keep in mind, I told you guys that CD and DC are different from each other, right? They're different because it would change the direction. Now it wouldn't change the magnitude, but it would definitely change the direction. Remember, magnitude means length. So if I instead connected D to C, so instead of this being the tail, I make C the tail and D the head, right? That's going to drastically change the direction. It doesn't change the length of it though. Okay, so to find that, we're going to do C minus D. So that would be 7 minus -2 and -3 minus -2, which would give us 9, -1. So in that one, it would be here, right? So it doesn't change the magnitude, but it changes the direction. Now it's an angle that's in quadrant 4, right? So you really have to pay attention on your test quizzes and mini checks. Are we doing CD or are we doing DC? Because that drastically changes the problem. Now, as I told you before, if we see these absolute value bars, that means magnitude, right? Which means the length of the vector. So I want to find the length of CD. So the length of CD would be the square root of x squared plus y squared. So we're going to do the square root of x squared plus y squared, which would give us the square root of 82, which does not simplify, so that's our final answer. So square root of 82. So I'm going to leave 4 and 5 for you guys to try on your own. It gives you A and B, and it wants you to find BA in standard position and then the magnitude of AB. Now keep in mind, this is AB and this is BA, but if I'm finding the magnitude, the length wouldn't change, right? So regardless, once I find the standard position here, I can use it to help me find the magnitude. So in a number 6 here, it gives us a vector u and it gives us a vector v. So vector u is 1, -4. So 1, -4, maybe that's right here. Because it's represented in these vector notation, that means that it is in standard position, right? So it's not like this problem where they gave us 2 ordered pairs and we're finding it in standard position. This is giving us 2 vectors that are already in standard position, right? So this would be vector u, then vector v is 0, 8. So that'd be right here. Okay, so here's vector u, here's vector v, and we want to add the 2 vectors together. So in order to add the 2 vectors together, we're going to add their counterparts. So we're going to do n plus 0, and then -4 plus 8. So we're going to add the x's and add the y's, which gives us 1, 4. Which should make sense if I go 1, 4, right? If I connected this here, here's our triangle method, right? So that's what we were showing you on the last page, but algebraically, we just have to add the counterpoint parts. So subtraction, same thing. If we want to do v minus u, then we're going to do v, which would be 0 minus 1, and then 8 minus -4, which would give us -1, 12. Now we can also do scalar multiplication, which means I want to take half of v. So instead of v being 0, 8, I want it to be half of the length. So to do that, we're going to take half of 0 and half of 8, which would give us 0, 4. Now same thing here. If I want to do 2 times u plus 3 times v, pretty intuitive here. We're going to do 2 times our u vector plus 3 times our v vector. Remember, order of operations says we have to multiply before we can add, which would give us 2, -8, and then 0, 24, which would give us 2, 16. Okay. Now down here, remember I talked about that we can write vectors in 2 different ways. So 2i plus 3j is just a fancy way of saying 2, 3. And 5i minus j is just a fancy way of saying 5, -1. Now I don't suggest that we rewrite it like this and try to complete these problems in that way, because if it starts with i's and j's, then our answer should be in i's and j's. So we're going to complete these problems still in i's and j's. I'm just showing you that this guy and this guy are the same thing. So if I want to do 3 times v, that would be 2i plus 3j. Distribute here would give us 6i plus 9j. 2v minus 3w would be 2 times v minus 3 times w. Distribute. And then combine your like terms. So we'll combine our i's here to give us -11i, and then combine our j's, which would give us -3j. Oops, this was a plus. It should be +9. Okay, then number 9 here wants us to find 3v minus w, and then find the magnitude of that. So we first have to find 3v minus w. So we're going to have 3 times v minus w combine our like terms. That gives us I plus 10j. But that's not our answer because it wants us to find the magnitude. So now to find the magnitude, to find the length, we're going to have the square root of 1 squared plus 10 squared, which would give us 101, which cannot simplify. So that is our final answer.